In surveying, one of the challenging tasks is determination of surface area. This is because most of the fields have irregular shapes. When encountering such fields, it is difficult to have direct calculation. However, utilizing the formula for area of basic geometrical shapes, this task can be done easily. By doing so, it is important to bear in mind that unlike regular polygons, fields may come in complex shapes and curved sides. With this, it is best to approximate the field as simple shapes and curves as straight edges. This fieldwork activity aims to develop and acquire the skills of determining the area of a polygon in the field using tape by dividing the area into triangles. Conducting three different procedures will help the surveyor deal with situations with different data given. Instruments and accessories needed includes range poles, measuring tape, markers can be either chalk or marking pins, and plumb box. Procedure A is about determining the area using base and altitude. For the area to be measured, the instructor assigned 5 points on the field for the students to be marked as points A, B, C, D, and E. These points will serve as the corners of the polygon. From here, a person called the chief of party will take over. It is his job to form 3 triangles out of the given points while considering that each triangle can be measured easily. The triangles will be named A1, A2, and A3. Other members will then get the altitude and base of each triangle. As for the base, members will choose any side of the first triangle and simply measure its length. Meanwhile, in measuring the altitude, it is important to note that it should be perpendicular to the base and at the same time will coincide to the remaining vertex of the triangle. To make sure that the altitude is perpendicular to the base, make use of the principle of the right triangle. For instance, the multiples of 3, 4, 5. Assign 30 cm along the altitude and from its bottom, measure 40 cm along the base. In measuring the hypotenuse of these lines, the tape should read 50 cm. If not, adjust the vertical side of the right triangle. Upon getting the correct hypotenuse, measure the length of the vertical side of the triangle, since this will serve as the altitude. Same process will be done on the remaining 2 triangles. The area of the triangles will then be computed using the respective bases and altitudes through this formula. A sub t is equal to 1/2 of base times height. The summation of the area of all triangles will yield the value of the total surface area of the irregular shaped field. The next method is by 2 sides and an included angle. In this method, we'll be using the same polygon described on the first method but changing the designations of the corners. In this case, we'll be using F, G, H, I, and J as our 5 points instead of A, B, C, D, and E. After doing so, divide the polygon into 3 triangles labeled as A1, A2, and A3. Next, we'll measure the 2 sides of each triangle named as A and B and the value of the angle between them. To get the area of each triangle, we divide by 2 the product of the sides A and B and the sine of the included angle. To get the total area of the polygon, take the sum of the area of each individual triangle. So that's the second method. This last method is by Heron's formula or by 3 sides. So once again, we will be using the polygon for this method, but once again changing the designations on the corners of the polygon. We'll be using K, L, M, N, and O instead of A, B, C, D, E, and F, G, H, I, and J. In doing so, label the 3 triangles once more as A1, A2, and A3 after you divide them. Afterwards, we'll measure the sides of each triangle and label them as A, B, and C. To get the semi-perimeter of each individual triangle, we divide by 2 the sum of the sides A, B, and C on each respective triangle. To determine the area of each individual triangle, we'll use the values of the semi-perimeter, side A, side B, and side C on the equation Heron's formula, which is the square root of S multiplied by the difference of S and A times S minus B and S minus C, where S is the semi-perimeter. To get the total area of the polygon, take the sum of the area of each individual triangle. And that concludes our video presentation. Thank you for watching and have a great day ahead.